Just like Paul, where he had a team of scientists together, we had a similar type of approach. And actually, I think when the proposals were written a couple years ago, we actually, I think, had about 4 or 5 proposals that were kind of packaged together administratively under one overarching project. And then Brian LaPointe and I had another project that we have woven in here. Plus, you've heard a lot about the Lobos, and I'm going to try to show you that that's also being brought into that. So here's our team. Brian and I, we've got tremendous technician support, and I've also added Ben and Jimmy because they've been very instrumental in getting us going on the Lobo project in particularly. And we've had a number of students and interns over that period of time. And I think you all know about the lagoon. I don't really have to say much more. You're pretty much a captive audience. So whether you argue it from biodiversity and ecology or just aesthetics or the economic worth, we know that it's very significant, and we know that it's in a state of transition that actually has been going on a lot longer than just the last couple of years where it's received a lot more attention. And I think most of you know the many, many issues that we have, and this is kind of my short list always. And the top ones really have to do with freshwater discharges that historically did not happen. They went down that water flowed down the center of the state through other natural systems. And that degradation of water quality leads to a lot of other issues such as these. The observatory is an attempt to really take a long-term, multidisciplinary view on the Indian River ecosystem. And I think we all realize that there was a time when scientists just studied what was natural. None of us really do that anymore. We all study how humans interact with the environment. And more the students that are just starting their careers now, that's what they're going to be doing for the rest of their careers, is looking at conservation science and restoration ecology, things that really didn't exist just a couple years ago. And especially in the lagoon, even as Margaret mentioned early on, there's a tremendous interest and tremendous impact by the surrounding communities. So our goal is to acquire and disseminate data and knowledge on the components of the IRL critical to its ecological function and its sustainable management. So there's a lot of fundamental science here, but it has to have a very strong application. And I'm going to address a series of points here about each of those key attributes that go from the fact that in order to do multidisciplinary ecosystem work, you really need to engage with a lot of other folks and not necessarily just within Harbor Branch, of course. And also we need to start to talk about how we can better use technology. Margaret said something about no whales in the Indian River Lagoon. There's one. Anyway, the overall model is what we do on land through the various loadings that mostly come in through canals, but also things like the atmosphere as well, really impacts the water quality. And water quality, why I'm so involved with this is the key interface, in my opinion, has to do with some of the very productive plant communities, especially seagrasses. And seagrasses, as you know, foster a lot of the biodiversity and the productivity of the lagoon for all the animals, all the fishes. Initially, this was launched in 2005, a series of stations. We started with 4, and after a couple years, it became 6 stations. They go from the northern part of Grand Harbor up here down to almost the Fort Pierce Inlet, down towards St. Lucie Village to the south. And we mostly are looking at that water flow that comes out of those canals. We have a lot of things we do routinely. Some of it can be done automatically with data sounds that can measure a certain basic parameters. We do additional weekly measurements of other key water quality, including nutrients, which of course now everybody's interested in. And so we start to get long-term data records like this. Salinity I always like to use because everybody kind of understands salinity. And because all of the other impacts are tied to water discharge, hence they're all tied to salinity. You can see that during the course of this whole series, each year kind of is different. I would say about the only 2 that look similar are maybe the last 2 have a lot of similarities to it. A lot of the downs, a lot of the decreases in salinity are very fast. So one of the values of long-term monitoring is you need to be monitoring, it has to be in place before you have that hurricane, before you have that unprecedented 50-year cold spell. And that's what we're attempting to do here. And I should point out that we've been in a drought for more than 10 years. And so actually, this has actually been a good situation overall for water quality. The drought is most noticeable in this particular period in 2010. That's when it was most noticeable in the data set. You can summarize a lot of data. Like you can take all of those points on the last slide, and here's your salinity patterns. So if you go from Vero Beach south, you have depressed salinity near Vero Beach, which increases toward the inlet. Nutrients are much higher in Vero Beach, both nitrogen and phosphorus. Chlorophyll is higher at the edge of where the fresh water flows down toward the rest of the estuary. For a plant person like me, we like to look at how much light is being attenuated. The higher this number, the darker it is for the seagrasses. And these are very high numbers, attenuation coefficients, relative to the downstream stations. So how does that impact seagrasses, and why do we care? Hopefully I don't have to convince you anymore that we should care about seagrasses, but if you have any doubts, without the seagrass, we wouldn't have the extensive fisheries, we wouldn't have the extensive diversity that we do. Other people have calculated the value of seagrass in terms of the services and the fish that it provides us. The estimates go from $10,000 to $20,000 an acre every year. We don't pay that. That's just what we get from nature. So I use the more conservative 10,000 figure. So being a plant guy, it's important to point out that there's very few seagrass species in the world. There's only 7 in the Indian River Lagoon, but that's more than anywhere else in North America. And the challenge is light. They need a lot of light because they're basically a vascular plant. They're like a terrestrial plant that has evolved to go back in the ocean. And it faces not only salinity, but it faces hydrogen sulfide in the sediments, very potentially toxic situation. So I did some work, actually it's been about 20 years, hard to believe, and it got put out in a very thick document through the Water Management District that funded it. But that was the first time anybody had really done kind of a lagoon-wide look at light, photosynthetic active radiation, how it tied to water quality, and how it tied to seagrasses. And going through 500 pages, I can just say I can reduce it to 3 there for this. What is most challenging is turbidity has the biggest impact on light attenuation throughout the lagoon. That followed by water color. Water color is natural. It's tied to fresh water. It's a result of decaying vegetation and freshwater plants. And then lastly, chlorophyll A. Now it's really interesting, some of the work we're doing now, because we like to go back and see how that's changed in 20 years. Because I'm going to think that it's not the same, which is going to be really interesting to find out if that's true. So one of the things we do is monitor the seagrass beds at those sites. And you can see that the most northern sites have shorter, much shorter seagrass beds. There's standard procedures now for monitoring seagrass in the lagoon for about the last 20 years. And these are very small seagrass beds in the Vero Beach area. As you go further away, Linkport, by the way, that's Harbor Branch, is right here. We do this twice a year. And so there's always 2 bars for each year. And the thing is, although this graph, because we're showing so many small beds and large beds, you can see the seagrass die-off. We did experience it in the Vero Beach area. A lot of decreases here. This is southern Vero Beach near Oslo Road. Interestingly, Harbor Branch is the beginning of the part of the lagoon where we did not see any major losses of seagrasses. One exception we had this past winter, which we're very anxious to see how that works out this summer, because that's the key time, is we actually had a drop-off at St. Lucie Village that wasn't trivial. It was very significant. So the story was, for many years, that the seagrass beds were either improving or staying the same, but not really declining. And that's heavily tied, hopefully just with this short presentation, you see the relationship to just some very simple water quality summaries with this pattern. And also, when you have the small beds, the stress beds in Vero, you always have mostly, that's the top 3 pies, you mostly have one species, shoalgrass or haliduli. So it's very monotypic. So there's not a lot of diversity in the bed. And Grant Gilmore, for example, over the years has shown you really need diversity of seagrasses. You need to have a mixed bed to really have maximum biodiversity. As you go further to the south, the lower 3 pies, you see we get a lot of other species, including the larger and more recognized as being the dominant plants, climax plants of Thalassia or turtlegrass and Syringodium or manatee grass. So we have, even in this very short distance, and most of us, we live in this immediate area, we have an incredible water quality gradient, and we have an incredible change of what we have in our seagrass beds. And again, I'm just going to highlight the importance of light attenuation. And that's really just a very plant perspective. I know most of us in the room don't think about that too much, but that is really what drives this local situation. Other people have been monitoring as well. So this is a summary that's put together by the St. Johns River Water Management District. And basically, for a period of time, 20 years, the overall trend was upward, both in terms of seagrass length and total coverage based on aerial surveys and ground truthing. And that was a very good thing. So 2 years ago, I would have said, wow, everything's great. We're watching seagrasses improve. Let's see what happens, correlated with that. But then, as you know, we had this unusual bloom in 2011. And again, this is data from the Water Management District. But I want to put our work in context to that. And some of those stations go back to that thing that I did 20 years ago. Some of those first stations were my stations from that work. And you can see, just like I described, we're at a very interesting spot here, where we're at the southern edge of the seagrass die-off. And interestingly, the southern part of the lagoon, during this period of time, it's always important to say during this period of time because it changes so much, I actually had major increases at some sites in seagrasses. So it's a really mixed community. That's why when people call up and say, what's going on with the lagoon? Is it healthy or not healthy? You can't just give it a one simple answer. You have to say, well, this time, this place, this is what's going on. So what we're trying to do is really to get a much better handle on the overall dynamics of this. For those of you, everyone says, what is that alga? Well, it's Rosaltor. This is an electron micrograph over here. And it's never been seen before in a lagoon. And basically 45% of the seagrasses in the whole lagoon were lost in a very short period of time. There was a follow-up the following year with a brown tide, but the actual brown tide impacts were much less. Brian's work, what's really interesting about working with this now is I'm focused really on this very localized, intense area where I got this really nice water quality rating. But it's important, especially when we see such a thing as the die-off and how also it's inconsistent throughout the entire lagoon. So Brian has been using macroalgae as nutrient indicators. And Paul already gave you a nice little update on what they can do with nutrients. Basically, macroalgae will take up whatever in the water. So they're very good at telling you over periods of time, integrating what the water quality conditions are. So especially, he's been working with nitrogen and phosphorus. And we're very interested, of course, in getting this data over very quickly to the agencies and other people who are able to do things about that. And very briefly, this is his salinity data from north to south. So it's north is on the left to the south. So that's Mosquito Lagoon, Banana River, Northern IRL, Central IRL, and Southern IRL. References near shore coastal waters. And you can see, for example, where we're here in the Central Indian River Lagoon. You can see that there's quite a lot of difference between dry season and wet season. That's a pattern overall, but you can see it's particularly true for where we are. So again, trying to hook that a little bit with what I'm doing. With Brian's data, you can see where we are in the lagoon, we have very high inorganic nitrogen. We have very high inorganic phosphorus. And also, Brian uses isotopes, which can give you kind of a trace, can tell you potential sources of it. And you can see what is different about everywhere else is that these are high values for delta 15 nitrogen. And let me just say that the higher you get above about this line that I'm drawing very waverly here, that is usually an indicator of sewage, aka septic systems. So Brian's going to be studying that a lot more, and you may have saw some articles in the newspaper about that. Lobos, very quickly, is our beginning to do technology. This is our team putting the first one out at the end of our channel. It has all the capabilities of what I just told you. It has all the capabilities of that, but then a lot more, including the fact that this will be beamed to all of us 24/7 live. So we'll have the data for anybody who wants to use it. We have phosphorus that's done real time by a chemical technique. We have a real-time optical sensor for nitrate. So all these issues that everybody wants to know, we now have the capabilities. This is what our website will look like. It's going to be very important also not only for researchers and agencies, but for the average person and for the schools and teachers. We'll be developing a lot of programs. You all know about the symposium. I don't need to tell you much. Most of you were there. This past year, what was really good was we added a second piece, which was the Lagoon Forum, with the idea of engaging more of the public and let them speak out. And there's going to be a lot of outcomes to that as we move forward. So I want to leave you with a message. If you haven't heard it before, The IRL is a very dynamic estuary. It varies tremendously in time and space. We've had a lot of impact for a long time. It's very challenging to manage. We are all part of this. We're all part of the pressure. Basic ecology is not known, and to understand that, we're going to require very sustained effort, scientific research and monitoring, and I think that we're in a really good position to be a catalyst for those efforts. So I think that's it.